Hey everybody, today we are going to start graphing polynomials. So the first thing we need to look at are the main four types of polynomials. Well, the first one is a linear equation, which would just be something like y equals x. So if I were to graph that line, it would just look like a line. And this line is positive because it's going up. Right, from left to right, it's going up. So we could have a line that has a negative slope, right? And that would be going down. So this one would be a negative line, but both are lines because it's linear, and we would know something's linear if we saw something like y equals x or y equals mx plus b. So a quadratic equation is something in the form y equals x squared. Now we know that we can have different transformations and different shapes and sizes, but overall a quadratic is a parabola, and this one we would call positive because it's going up. And if we draw one that's negative, it would be going down. So a cubic graph is something that you may never have seen before. So that's something like y equals x to the third. And a cubic function looks like this. Okay, because if you, let's say you took the number 2 and you raise it to the third power, you'd get all the way up to 8. But if you did 1 cubed, you'd be at 1. So you can always use an xy table to construct these graphs, but this one, as x approaches positive infinity, right, as I go to the right, my graph is going up, so we consider this positive. And if we were to have a negative version, we would have to reflect it, and this one would be negative. And that's going down as x gets bigger. And quartic is y equals x to the fourth. And its general shape is kind of like a W. And this one's positive. You'll see that if we look at the end behavior, the end-to-end behavior all the way to the right, they're all going up. And then if it's negative, it would be going down. But you have to be careful. Sometimes the quartic could just look like a parabola. So it's not always this W shape. It does sometimes look more like a parabola, depending on the equation. The size of its curves are a little bit smaller, but you'll know it's quartic by the equation because it has x to the fourth. Okay, so we have important pieces of equations that we need to be able to identify: the degree, the type, and the leading coefficient. So the degree is the highest degree exponent. So I'm going to rewrite this. So this x to the fourth is first because we want it to go from biggest to smallest. So 3x to the fourth plus x squared plus x plus 7. So the highest exponent is 4. So we say the degree is 4. This is a quartic. The type is quartic. Every x to the fourth is what we classify as quartic. That's what we wrote up here. And the leading coefficient. The leading coefficient is just the number in front of that term that has the highest exponent. So this leading coefficient is -3. So part B, the degree is 3 because the highest exponent is 3, which makes it a cubic function. And the leading coefficient is +3 because that is the number that's in front of that x term with the highest exponent. And lastly, we have x squared minus 1. So the exponent is 2. which makes it a quadratic. And the leading coefficient, well, there's no number there because it's a 1, right? 1 times anything is itself. So that's how you identify the degree, the type, and the leading coefficient. And that's important to be able to graph these polynomials because if we don't know the type or the degree, we don't really know the general shape. So let's describe the end behavior. So as x, we're going to be using a statement like this every time. As x approaches positive infinity, f of x, which is just the y values, approach something. You're going to put a number there. And as x approaches negative infinity, y approaches some number also. So first we need to find out the degree and the shape, and then we can figure out the type, the end behavior. So this is a quartic function, right? Because it has x to the 4th. If you want to rewrite it, you can. You don't really have to in this case, but you can. And this is a quartic. Now, the leading coefficient here is negative. So without using my calculator, I can find the general shape. It is upside down u because it's quartic and it's negative. But if you go to your calculator, you'll see that and you type this into y equals, and I would go to zoom 6, just in case you have a strange window going on, that your function doesn't have quite as big of a dip for that W shape, and that's okay. You could draw it a little bit more accurately, but the idea is that all we really care about is the end behavior. So as long as we know where the ends are supposed to go, and in this case they're clearly going down forever, we can come up with our end behavior. So we're trying to fill in the sentence. As x approaches positive infinity, f of x approaches some value. Okay, well, as x approaches positive infinity, that's as we go to the right. So I'm following it to the right. My pen is going down, right? This is the side I'm looking at when x approaches positive infinity. Well, if it's going down, that means y is approaching negative infinity. And as x approaches negative infinity, meaning I'm going to the left, right? As I go to the left, my graph, my y values are going down. So f of x approaches negative infinity. And so for both x positive and negative, remember that's left and right, your y values are both heading down, so they're both going to negative infinity. Okay, so part B, this is a cubic and the 3 is positive. So that means when I have my general shape of a cubic graph, it needs to end up. But just in case you're still not confident with the shapes in your calculator, let's type it in. 3x to the 3rd, and you should be typing this in 2 plus 2x minus 1. If I look at the graph, you'll see it has that general cubic shape, and it's all the way to the right is going up, what I call that the end. So as x approaches positive infinity, we're looking for what f of x approaches. So x approaching positive infinity is going to the right. Well, my graph is going up all the way to positive infinity because it's going to go on forever. As x approaches negative infinity, which is to the left, your y values are going down. So that means they're going to negative infinity. And that makes sense. One's going up, one's going down. They should have opposite end behaviors. So always double check to make sure that your conclusion makes sense. So this is a second degree polynomial, meaning it's a quadratic, meaning it's a parabola. So it's a parabola, it's positive, so that means Its general shape looks just like that. But again, we have these nice calculators to help us out. So x squared minus 1. Look at the graph. I have a parabola. All right, and mine looks the same, so that's good news. So I need to find the end behavior. So as x approaches positive infinity, that means as x goes to positive infinity, where are my y values going? They are going up. So f of x is approaching positive infinity, because this side is going to go all the way up to positive infinity. So as x approaches negative infinity, f of x approaches, well, as I go to the left to negative infinity, my y values are also going up to positive infinity. So those, and you can see in the picture, they have the same end behavior. So they should have the same end behavior when you write it out. All right, so this video is all about knowing the shape and the degrees of polynomials, leading coefficients, the types, as well as figuring out the end behavior. All right, if you have any questions, make sure you write them down on your note sheet so you don't forget to ask them the next time we meet. See you then.